Okay, in this video, we're going to learn about the average value of a function. We're going to be using integrals for this, and we can kind of springboard off into the mean value theorem for integrals as well. So to find the average value of a function, you just got to find the area underneath the function. That's it. And then divide that by b minus a, which is just my endpoint. So just like to find like the secant, kind of the same idea here, but you're just integrating here. And then you're starting it by the two endpoints. It's going to give you the average height, essentially, is what we're trying to do. We're trying to find, not the area. So we're going to find the area and divide that by the endpoints, which is going to give me the average height of a function. So, like, you have this function right here, kind of weird looking thing, right? Just woo, all over the place. But by using this formula, you can figure out that, oh, there's the average height right there. So essentially, you can take all of the area of this and transform it into a rectangle. So that's all they're doing, is just finding the average height for these functions. That's what average value is. The mean value theorem is going to be if f is continuous in a to b, then there exists a c in a to b such that. So it's really just saying that that height has to happen in that average value at some point. That's all it's saying. That height has to happen somewhere. Because again, it's continuous, it's not jumping, it's not skipping anywhere. So also can be rewritten this way as well. So it doesn't really matter how it's written. So let's go ahead and do some problems that deal with it. So first example, we're given a function 1 plus x squared on the interval from -1 to 2. We're going to go ahead and find the average value of f on the given interval. So before I do that, I'm actually going to kind of start part C here. Just because I want to sketch this real quick so we can kind of see what this looks like. So at -1 on here, we're going to get a height of 2. At 0, we get 1. At 1, we're going to get 1. And then at 2, we're going to get 5. So 1, 2, 3, 4, 5. So I'm just going to just throw it right up here. Right, so this is my best drawing, whatever. So we got to find the average height of this graph here. So I can kind of see that, you know, it's probably going to be somewhere in the 2s type of area, because if you look, this height repeats itself over here. So the average height probably isn't all the way up here. It's probably somewhere in this range right here, somewhere probably between 1 and 3 is my guess. 1 happens only one time, all right? 2 happens twice, and 3 happens one time, so it's probably closer to the 2. So, all right, knowing that, a little bit of estimating can always help us out with our answer, because we know if we get like an answer of 5, we did something wrong, okay? So let's go ahead and set this up. So this is going to be the average value of the function is 1 over the endpoint, so 2 minus -1. And that's the integral from -1 to 2 of 1 plus x squared dx. And do not forget that dx. People like to forget it. Don't forget it. All right, so it's going to give me a 1/3 antiderivative of 1 plus x squared is going to be x plus 1/3 x cubed. Evaluate that from -1, the bottom bound, to 2 is the top bound. So that's going to give me 1/3 of, well, 2 plus 1/3 times 2 cubed minus -1 plus 1/3 -1 cubed. All right, so you can go through all of that lovely math here. I'm going to, again, save you the trouble of doing the arithmetic right in front of you. You should be able to figure out this arithmetic on your own, okay? So this is going to give me an answer of, when it's all said and done, answer of 1/3 times 6. So this inside here is going to give me a 6, which is going to equal a 2. So the average value of this is going to be 2. And I kind of mentioned how it's probably somewhere around 2. And, well, this average value is 2. Okay? So let's find C such that where the average equals the actual function itself. So we're going to plug in the 2 and set this equal to the function. And we use x for right now, and then we need to graduate this stuff into there. See if my C values are inside of here. It should be. So go ahead and solve for this. We're going to get 1 equals x squared, square root both sides. You're going to get plus and minus. So x is going to equal plus and minus 1. So I need to graduate to a C. Now this is where it can get just a little bit kind of like, wait a minute. That don't make no sense. Only one's going to graduate to the C. The reason that -1 does not graduate is because it's an endpoint. So we don't include endpoints when we do the mean value theorem for integrals. Just giving you a little bit of a heads up there. That's why I did this example, so I can just show you the weird things that go on. So only C graduates. So just kind of be aware of that. So yeah, so can't use endpoints. So it does touch C that one time when I'm going from endpoint to endpoint. That's the thing, going from one endpoint to another. We're not including them. So part C here just says sketch F. Did that in the beginning so we can see what the heck is going on. And then whose area is the same as graph of F. So now when I sketch this in, I don't know, maroon, I'm going to sketch a rectangle with the base from here to here with a height of 2. So sketch this bad boy right here. So this rectangle, that is, I'm going to just dash it with maroon, has the same area as everything underneath this function. And I will dash this with black. So these two areas are completely equal. If you see that they overlap, except for this little part right here and that little part right there, so those little parts are equal. All right. So that's a little of a visual of what the heck is going on. Now let's go ahead and go to a word problem. All right. Suppose that a typical winter day in Minneapolis, the temperature in degrees Celsius, X hours after midnight, is shown to the figure in the right. So this one just gives us the graph. We're to use a midpoint Riemann sum. We have not done that in the notes yet. With 4 equal subintervals to approximate the average temperature over a time period from 4 a.m. to 8 p.m. So if I'm looking over here, 4 a.m. is the first 4, because it happens first, and 8 p.m. is the second 8, if that makes sense. So we kind of have to go to military time here. So it's not from here to here. 8 p.m. in military time is 20 hours. So we're going to go from here to here. Okay. And I want 4 equal subintervals. So that's going to be, there's 16 between 4 and 20. So divide that by 4 is going to give me 4. So every single 4s is what I am looking at. Okay. So since I'm trying to find the average temperature, so the average height of this graph between 4 and 20, if I'm looking at it, it's probably somewhere around 0, right? So it kind of like doubles up right here. So I bet you it's somewhere around 0 is the average temperature. So set this up. We're going to go from 1 over 20 minus 4. Integrate from 4 to 20 of this function. Just doesn't tell us what the function is. I'm just going to call it f of x dx. Using Riemann sum, so I'm just going to use the approximate sign. It's 1 over 16 of, well, let's go through it now. So the midpoint, so first off, the width from 4 to 8, because again, we need to, there's going to be rectangles here, so it's base times height. So the width here is going to be 4 times the height of f of 6. because it's a midpoint. What's between 4 and 8? It's 6, and I'll plug that in just a second. Plus, from 8 to 12, it has a width of 4 times f of 10. Whoop, too many parentheses. Oh well. Plus 4 times f of 14. Plus, again, a width of 4 times f of between 16 and 20 is 18. So if you notice, all these numbers I'm picking, 6, 10, 14, 18, are the numbers that are smack dab in the middle here. Okay? So as I'm going through this, so this is going to be about right here. I'm going to try to stick to whole numbers for my estimates. Okay. So this is my first rectangle, which is the 4 times f of 6. So this would be 4 times, so it's 1/16. 4 times, was it -5? Okay. Plus, this next one is going to be about right here. Again, I just want to use nice, clean integers here. So this would be 4 times 1 plus, this looks nice and maybe not exact here. Again, we're just estimating here because I don't have the actual numbers. So we're looking at that height right there. And that's going to be 4 times, let's just say 2. Plus 4 times, now let's look at 18. 18 is going to be about right here. What the heck number did I use in my notes here? I can't tell, my notes are so faded. Negative what? Negative, I feel like it's bigger than 1. Maybe for giggles here, let's just do, it's negative, it's getting a little bit closer to the 2, so let's do 1.5, which is 3/2, so -3/2. Okay, so let's go ahead and I'll do the arithmetic now because I can't read my own writing over here. So we're going to put this all right here. We're going to get 1/16 times -20 plus 4 plus 8 minus, this is going to be 6. All right, so this is going to give me an answer of 1/16 times, isn't it so fun watching me do arithmetic? This is why I don't really care to do the arithmetic in front of all of you. What is this? -16, -8, -14, which is going to give me -14/16, which is a perfectly awesome answer. You don't need to simplify, but I will so that I can use the graph because it's easier if it's more simplified for me. This is going to be -7/8 units here is going to be, it's an average height, so it's the average value here is just going to be degrees Celsius. Okay, so my average height, that's close enough to what I got there with my arithmetic. -7/8. That's the average temperature here. So the average height. So that's going to be about right here. A little dashed purple line. So that's the average height. So use your answer at A to estimate when the time when the average temperature occurred. So just look at my purple line. Where does it intersect right here? Intersects right there. Looks like at 9. So it's going to intersect at. So first off, we're going to plot y equals -7/8. We did that. Okay, it's plotted. And where does it intersect? So it intersects at about x equals 9 and 17, which is going to give me 9 a.m. And the military time here is going to be 5 p.m. So these are the times, or you could say at 9 and 17 hours after midnight. Okay. You can use x equals as well. Sorry, that was so crooked. You can use x equals as well because it says that variables will be x. So there you go. There is the average value word problem. And that's it.